Phase Drift just released on Android, and one of its major features is that the stages are different every time you play. It may come as a surprise then that this was not the original design of the game. I'm Will, and in this video I'm going to talk about why Phase Drift has procedural stages and how they work. In the early prototype of Phase Drift, enemies were being manually set into place and dragged under parent objects. This was fine for making a one-level prototype, but I knew that this would have to become an automated process. I created a script that would take in a pre-made texture and look at each pixel of it. It would ignore any clear pixels and use a lookup list to spawn enemies by corresponding colors. It would then use the pixel coordinates to spawn in the correct location and under the correct parent object. With that, I had a system where I could quickly make a new enemy setup just by moving a few pixels around. This was a huge help to development and changed the process of setting up enemies from one that took several minutes to one that took seconds. The system was all I was using for new levels for quite a while, but there were two major factors that led to the creation of procedural stages. The first of which was that it was becoming clear that the end game was not going to be the same as the original design. Phase Drift was actually going to have a prescribed set of levels that would come to an end. As the game shaped more, it became clear that the things that made the game fun went against that structure. So I needed to move to infinite levels. Rather than just picking from a large set of existing levels, I decided to generate them at runtime. That's not just because it provides better replay value, but also because it's actually quite a bit less work, even if it requires a bit more cleverness. Going this route also solved a second issue for the game. Phase Drift can be very difficult, and players would often be playing the beginning stages many times over. I had already implemented systems that keep this in mind, such as the music system, which doesn't restart the music when you die, and continuously shuffles through all the tracks you have unlocked. The deeper issue here was that players would still be replaying the same stages, and if I was going to make a system of random levels at the end of the game, and I was going to use it for the early game as well. Since I already had a system for generating a level from a pixel texture, it made sense to stay within that. So I wanted the output of the stage generation to be a texture that would work in that way. There are several ways I could have tackled this, but I decided the best way was to take several smaller textures and overlay them on top of each other. I might have a texture like this for the base enemies, and another two for other enemy types. The system first makes a copy of the first texture, as not to overwrite it, then for the second texture, it loops through each pixel, and each one that isn't clear gets copied to the stage's texture, overriding whatever is there. It then repeats this process for each of the enemy layouts. For each enemy, there are dozens of textures for different configurations, and they're arranged by difficulty. For example, the Python, or diving enemy, has different sets of templates for easy, medium, and hard, with around 3, 5, or 8 instances of the enemy in each template. There are about 30 different configurations for each of these difficulties. When the algorithm is told to use the diving easy set, it will randomly select one of the templates that match that description. When this technique is multiplied by running similar odds on each enemy included on a given stage, the number of possible combinations skyrockets. The system is set up so that I can call out in string form which enemies I'd like to have in a stage, and at what difficulty, and it will automatically run through all the steps necessary to create the stage. This makes it so that I can still predefine what kind of encounters the player will have without setting in stone exactly how they will be arranged. This allows me to guarantee that players won't begin to face harder enemies until they are ready. For a better understanding of the ins and outs of the system, let's walk through a theoretical stage being generated and see what happens. The access to the generation system is through the createLevel method, which has a textured 2D return type to match the input of the existing system. The first thing this method does is grab an array of strings which will contain the information about what enemies are in the stage. To get these strings, the first thing we do is get information about what sector and stage we're on. This information is held in the Run Controller class. Each sector is made up of 4 stages and 1 shop. Since the Run Controller holds the overall stage as a single integer, the sector and stage can be found with a bit of math. Next, there's a check to see if we're drawing from a pool of predefined levels or from a more random set. For the sake of this example, we'll assume the stage is 2-4 to not overcomplicate it. So the pre-made levels method will be called, which takes our sector and stage and returns a string array that will be passed back up to the first method. Since our example is for 2-4, this will skip over the levels for sector 1 and go straight to sector 2. It then plugs in the stage to a switch statement, which will bring us down to the 4th case. This string array will be passed back up to the first method. It's good to note here that the names of the enemies look a bit funky. This is because I wrote this method before all of them had customer-facing names. As a matter of fact, the only place where the enemies are specifically named is in the achievements. Now that we have a list of enemies for this stage, we need to adjust the length of the array to make sure it will plug into the next method properly. The following system is set up to ignore empty strings, so we create a string array filled with them and just replace the ones that we're actually using. It's better to do it this way rather than filling them in where the stages are listed, in case we need to change the number of inputs. I actually needed to do that at one point and was glad that I could just adjust a few lines of code rather than dozens. With all of that completed, it's time to dig into the meat of it. This method takes in up to 5 names of enemy template sets. The first thing it does is convert all of those strings into single templates. This is where all of the large arrays of different template possibilities collapse into just the ones we'll be using to generate this level. It does this by calling the text-from-array method, which takes in an array of possible templates and a list of ints corresponding to which of those templates have already been used. So first it needs to find those using 2 other methods. Each of these is just a long switch statement. It takes in the name of the enemy and difficulty and returns a pre-made array of templates. For the case of the used template positions, this bit actually proved to be unnecessary. The idea is to keep track of which templates have been used so that the system is guaranteed to never pick the same templates multiple times in a row. Unfortunately, this would have relied on returning a reference to the list rather than making a copy of it. This can be done in C#, but just not the outdated version that Unity uses. I left it in anyways, as it doesn't hurt the script, and Unity has promised to update the version of C# it uses at some point. Now that we have that all sorted out, we can plug them in to get the textures for the stage. This first bit handles the empty strings mentioned earlier. Blank text just returns a texture of all transparent pixels, so that won't affect our stage generation. Assuming we didn't have an empty string, we'll pick a random index from our array, plug that in, and return our texture. Once we've done that for each of the possible 5 enemies, we can start generating the actual texture for the level. We'll start with a blank base texture, then overlap every enemy template captured above. The overlap enemy method takes in the overlap texture and a reference to the base texture. It loops through every pixel on the texture, and if that pixel is not transparent, it will overwrite whatever is in that position on the base texture. After this is done for every enemy template, the stage texture is complete and can be returned all the way back to where create level was called. It can then be passed into the existing system, which spawns in the enemies. Phase Drift is available right now on Android, and it's free. So if you watch this video and you have an Android device, there's no reason you shouldn't go check it out right now. Thank you ever so much for watching.